completing the square for x squared plus bx plus c equals 0. Your strategy for solving these quadratic equations should always be to isolate the x squared and x terms on one side of the equation and then complete the square on that side of the equation. And now there are other strategies which are similar and they'll produce correct results, but I'm trying to be really strict about this strategy because I want to limit the number of mistakes that you make. And I just feel like if you're really consistent with this, you'll more consistently solve these problems correctly. So we're going to solve x squared plus 8x equals 48 by completing the square. Now, some of these, you can solve them by completing the square because they're unfactorable. Other of these actually could be factored to solve them, but we just want practice completing the square, so we're going to use this technique. So in this example, we already have x squared plus 8x on the left-hand side. X squared plus 8x. And then I'm going to leave a gap after that and then say equals 48. So the terms with the x's are already on the left-hand side, so that's good. We don't have to rearrange this equation. And now what we're going to do is we're going to complete the square on the left-hand side. So we're taking that term, or that coefficient in front of the x, which is 8, and we're going to divide it by 2 and get 4. And then we're going to square 4 and get 16. So we are going to add 16 and then subtract 16 right away. Again, that means we're mathematically not altering the equation. We're basically adding a total of 0 to the left-hand side, but it's going to allow us to make a perfect square trinomial out of x squared plus 8x plus 16. So x squared plus 8x plus 16, we could write that as x plus 4 squared. And the way I get to x plus 4 squared, of course, is it's the square root of 16. So that's what's going to be there. As long as we follow that technique, it's going to be the square root of what we added. And it's positive because it's positive 8x in the coefficient of the x term. So now we still have this minus 16 because we just subtracted it, and 48. But now you can start to see that we're going to be able to solve this equation using the square root principle. So I'm going to add 16 to each side. So I have x plus 4 squared is equal to 48 plus 16. And 48 plus 16 in my calculator is 64. And from here, I'm going to use the square root, or sorry, not, the square root principle, which is to say that x plus 4, if it's x plus 4 squared equals 64, then x plus 4 must be equal to plus or minus the square root of 64. The square root of 64, well, that's a perfect square, so I'm going to simplify that to plus or minus 8. So I have x plus 4 equals plus or minus 8, so subtract 4 from each side, and I get x equals negative 4 plus or minus 8. This is not a good way to write the final answer because we can simplify this really easily by separating this into x equals, so I'm going to give myself a little more room up here, x equals minus 4 plus 8, or x equals minus 4 minus 8. These are just integer solutions. So x equals 4 or x equals negative 12. And there's my solution. So we've solved this equation by completing the square. And always a good idea, if you have the time, to check your solutions by plugging them back into the equation and making sure it works. Now, if we have an equation where one side is factored, if we had equals to 0, great, we could use the zero product rule. But we have x minus 3 times x plus 5 equals 9, and the only way we're going to be able to solve this is by expanding the left-hand side out and rearranging our equation. So let's get ahead and start foiling. X squared plus 5x minus 3x minus 15 equals 9. And then get our x squareds to the left-hand side, or leave the x terms on the left-hand side, so that'd be x squared plus 2x, and then move the 15 over to the right-hand side. So add 15. Oh, and don't forget to leave that gap after 2x. So then we have 9 plus 15 is 24. And now we're ready to complete the square. 2 is a nice number for completing the square because we start with 2, we divide by 2, and we get 1, and then we square 1, and we get 1. So we add 1, and then we subtract 1, and here is our perfect square trinomial. So we can factor that into x plus 1 squared minus 1 equals 24. And I'll add that 1 to each side to get 25. And now we'll take the square root. So x plus 1 is equal to the positive or negative square root of 25. And that is, of course, just 5. So I have x plus 1 equals 5. And x is equal to negative 1 plus or minus 5. So either x is negative 1 plus 5, which is positive 4, or x is negative 1 minus 5, which is negative 6. Lastly, we just need to accept the fact that we will have to use fractions to complete the square. There's no fighting it. It's just going to have to happen. So if we want to solve n squared equals 3n plus 11, the way to do this is to get the n terms to one side. So we subtract 3n from each side. And then we have n squared minus 3n equals 11. Now, we're going to go ahead and complete the square on the left-hand side. So actually what I should have done is leave a gap between negative 3n and 11, so I have room to complete the square. But I'm going to have to use this negative 3 to complete the square. So negative 3 over 2, that's it. It's negative 3 over 2. And then I square it, and negative 3 over 2 squared is 9 over 4. So to complete the square on the left-hand side of the equation, I have to add 9 over 4 and then subtract 9 over 4. I have a perfect square trinomial there. I know it's a perfect square trinomial because we proved earlier on that whenever we do this, we produce a perfect square trinomial. So this is going to be n minus, and then it's the square root of this term here, which we actually have from back when we divided negative 3 by 2. So it's going to be negative 3 over 2. N minus 3 over 2 squared is that completed square. And then I'm going to add 11 plus 9 over 4. So add 9 over 4 to each side. That's what I'm doing there. And I have to combine 11 and 9 over 4. So to do that, give them a common denominator. So that'd be 44 over 4 plus 9 over 4. So that would be 53 over 4 on the right-hand side. So it's not pretty, but it is what it is. And we just have to accept the fact that we're going to have fractions in some of these questions. I'm going to continue my work over here on the right. So now that I have something squared equals 53 over 4, I can say n minus 3 over 2 is equal to positive or negative the square root of 53 over 4. So n is equal to 3 halves plus or minus the square root of 53 over the square root of 4, which is 2. And I can combine those two fractions because they have a common denominator. So it'd be 3 plus or minus the square root of 53 over 2. And there's my solution to that equation.